Hey again, it's Mr. Lum, and today we're going to be doing some more acid-base chemistry and talking about Ka and Kb constants, or in other words, the acid and base constants. So Ka and Kb is very, very similar to, again, Keq, and we use the same principles when we make up a Keq formula. So here is an acid expression. We know that this is an acid because it makes H3O+. Acids will always make H3O+, and bases will always make OH-. So since this is making an acid, we're going to give it a Ka value, A standing for acid. Now, we write it the exact same way as we would write a Keq expression. So again, H2S is aqueous, H2O is a liquid, H3O+ is aqueous, and HS- is also aqueous. Okay, so since H2O is a liquid, we don't put it into our Ka expression. So when we write our Ka expression, it is, well, it's products over reactants, is the concentration of products over the concentration of reactants. Or in other words, Ka equals the concentration of H3O plus and times the concentration of HS minus, now divided by, since water is a pure liquid, we don't add it in here, but instead we divide by H2S. Okay, and this is our Ka expression for this formula right here. Now, again, you always use Ka when you ever have H3O+ in your equation. Now for this one, since this is OH-, we're going to use Kb, and the B stands for base. Okay, and the exact same thing. CO3 minus 2 is aqueous, H2O is a liquid, HCO3 minus is aqueous, and this is also aqueous. So since this is a base, because we have the OH minus, we're going to call it Kb, and that is also products over reactants, which is HCO 3 minus multiplied against OH minus and divided by CO3. Now again, we don't add water because water is a liquid and the other ones have concentrations. This symbol again means concentration, so we only put things in our Kb expression with concentrations. Okay, so we see our acid and base table that we're given. Again, these ones right here are strong, and these are also strong bases. Now everything else in here is weak. This is, all of this is weak. And therefore they're going to have values, and we see these values here. Now we're given Ka values. Okay, so all of these are Kas. This is all Ka values, and they all form, as we see right here, all of them form H plus, which is the same as, for our purposes, this is the same as H3O plus. H plus and H3O plus is the same. So these are all Ka values. They're all showing the acid reaction of all of these things. And so what we're going to look at is, if you're given Ka, how do you calculate Kb? Okay, so again, this table only gives you Ka. So let's look at how you can calculate Kb. Now, Kb and Ka are related, and we're going to look at exactly how are these two things related. So let's look at, let's write up our Ka expression for this one right here really quickly. So again, Ka is equal to our products over our reactants, or in other words, our H3O plus times NO2 minus, divided by, again, water is a liquid, so we're not going to use water, and HNO2. So here's our Ka expression, and here's our Kb expression. So Kb is our concentration of OH minus, and times our concentration of HNO2, and divided by, again, this is a water, which is a liquid, so we're not going to use that, so divided by our NO2 minus. Okay, so how is Ka related to Kb? Well, we're going to try doing this. We're going to multiply Ka times Kb to see what we get here. So if I were to take this Ka expression and substitute it in right here, we would go Ka is H3O plus multiplied with NO2 minus divided by HNO2. Okay, so this is Ka right here. I'll write Ka right above it so you know. And we got that from up here. Now again, we're going to multiply this by Kb, and Kb is right here. So we're going to multiply this by Kb. And so again, I'll write Kb. Okay, so our Kb is right here. And that is OH minus HNO2 and divided by NO2 minus. So we have Ka times Kb. Now what we see is when we multiply these two things together, some of these can cancel out. Like HNO2 cancels with this HNO2. Okay? NO2 minus cancels with this NO2 minus. So in other words, what happens is Ka times Kb equals the concentration of H3O plus times the concentration of OH minus. Okay? Whoa, now this is looking very, very familiar. If you remember in our last lesson, H3O plus times the concentration of OH minus looks like something that we've seen before. Can you remember what we saw before? Remember this formula? H2O makes H plus and OH minus. That's the water constant. Kw equals H3O plus and H plus is the same thing, times OH minus. This is Kw. So Ka times Kb equals H3O plus times OH minus, which is also equal to Kw. So what you can also say is Kw is equal to Ka times Kb. Kw is also equal to Ka times Kb. So on a test, you don't ever have to derive this formula, but you do have to remember it. You have to memorize this formula. And this is how it is derived from. So again, Kw, or the water constant, is equal to Ka, or the acid constant, times the base constant. So Kw is equal Ka times Kb. And this is how we can get it from there. Okay, so now on our next page, let's look at a question where we use this in order to solve a problem. So this question says, what is Kb for this equation right here? Now, on our acid-base chart, we're given the Kas. So we look up on our acid-base chart and we find nitrous acid, which is HNO2, and it has a Ka value of 4.6 times 10 to the minus 4. So we know that Ka equals 4.6 times 10 to the minus 4. Okay. So we also know that Kw equals Ka times Kb. Okay, so now we also know that Kw equals 1.00 times 10 to the minus 14. So let's put in some of our numbers here and solve. So 1.00 times 10 to the minus 14 equals 4.6 times 10 to the minus 4th times Kb. Solve for Kb, and that is 1.00 times 10 to the minus 14th divided by 4.6 times 10 to the minus 4th equals Kb. And therefore, Kb, I've already solved this problem ahead of time, and Kb equals 2.17 times 10 to the minus 11. Now again, since this is two significant figures, our final answer is Kb equals 2.2 times 10 to the minus 11. Okay, and that's how we use Ka from their acid-base chart to find Kb. So if what we could say is, if we were given a sample of NO2 or maybe NaNO2, and we're asked to find the Kb equation, well, Na, this is a spectator ion, so we can ignore that, and that would just be NO2 minus, and then plus a water would make OH. Since it makes an OH, you know that it's going to be a base, or that you're going to be using a Kb value, and this is how you can solve the Kb value using the Ka value from your table. Okay?